Can see my screen now. Okay, that's
Yes, sir.
so. Where did we stop? Oh, we're treating the first example before my network just went bad. Please, if you are not talking, just off your speaker. Now, let's just go through this all over again. Okay, this example one, a researcher recorded the ages in years of 20 people and summarized the data as shown in the table below. Can you see my screen?
Yes,
Yes, sir,
Doc.
we can see.
Yes,
Okay. Now, a researcher recorded the ages in years of 20 people and summarized the data as shown in the table below. This is the ages, and of course, this is a grouped data. You know, the one we did yesterday was on grouped data. So today, this is a grouped data, and between 10 to 14, we have 3 persons. The frequency there is 3. Between 15 to 19, the frequency is 5. Between 20 to 24, we have 7. 25 to 29, we have 4. 30 to 34, we have just 1. Now we are required to find the mean, variance, and standard deviation of the ages. So for the class, just like in the question, we have them here 10 to 14 down to 30 to 34. We have the frequency here, the midpoint. How we got the midpoint is that for this class 10 to 14, all you need to do is to say 10 plus 14, which will give you 24, divide by 2, and that will give us 12 here. And quickly, without waste of time, how to get f of x, all you need to do is to multiply 12 by 3, multiply 12 by 3, that will give you 36. Excuse me, for x squared. You know, this is our value for x. So that's 12 times 12. That will give us 144. And fx squared, that will be fx squared, that will be 3 here times our x squared, and our x squared is 144, which you will get this value. Now, let me just do for the second one, and I will generalize that we'll obtain the rest following the same pattern. So this is for the class interval of 15 to 19. The frequency there is 5, and the midpoint there is 17. How do we get 17? 15, you go to the class interval. This is a lower class interval. This is the upper class interval. So all you need to do is to add them up. 15 plus 19, divide by, that's 34. Divide by 2, you will get 17. So 5 times 17, that's fx. That will give you 85. Now, how do we get 289? You come here, 17 squared is simply 17 times 17. When you say 17 squared, it's simply 17 times 17. When you say 17 cubed, it's simply 17 times 17 times 17. So in this case, we have 17 squared, and 17 squared is simply 17 times 17, which will give us 85. I mean, 17 times 17, which will give us 289. And of course, fx squared, you take this 5 here, you multiply it by 289, you will get 1445. If you had any issue how this table generated, sir, why are you on your microphone? Now, if you have any issue how we generated this table, we'll have like 1, 2, 3, 4, 5, 6 columns. If you have issue how we got any of the columns, this is the right time you ask your question. I'm waiting. Ask your question. Any question on this table?
Yes, sir. I have off my mic. Sorry, sir.
Ask your question. Are you not asking question? Are you asking question?
No, I'm not asking.
I'm waiting. Ask your question.
I'm okay with your explanation.
Okay, that's fine. That's fine. Let's make progress. Now, okay, to get our mean, you are required to sum all the frequencies, which we are calling summation F. That's 20. You sum this, 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 4, that's 19, 19 plus 1, that is 20. So summation F is 20. Next, we are required to sum f of x. Fx, Fx, all these values, you are required to sum them. And when you sum all the values of f of x here, you will get 415. Next, you are required to solve this. You are required to solve this. I mean, to sum this. When you sum fx squared, you will get 9205. 9205. Now, the mean is sum f of x all over sum f, which is equal to 415 divided by 20 is equal to 20.75. It's equal to 20.75. Any issue there? Let's be making progress together. Any issue there?
No issue, sir.
No, sir.
Nenda Steven, any issue? Mr. Steven, Mr. Peter, Madam Chuku, Madam Agatha, Sister Patience. Where is Sister Patience?
I'm with you, sir. I'm trying to catch up on the midpoint of X.
Okay, how we got midpoint?
Yes, sir. And that's what I'm using my head to do.
No, you don't need to use your head. How we got midpoint is this class interval 10 to 14. Add 10 plus 14 divided by 2. 10 plus 14 is 24. 24 divided by 2 gives us 12.
Okay, sir.
Are you still having issue?
No. I'm picking it up now.
Immediately, when I make some of this explanation, you write it down immediately. How do you get midpoint? Is this 10 plus 14 divided by 2, you have 12. If you come to the last one here, 30 plus 34 is 64. Divided by 2, you have 32. Sister Patience, any issue there?
No, I've gotten it. Thank you very much, sir.
You're welcome. So getting the mean now is the summation of f times x all over the summation of f. And this will give you 415 all over 20, which is equal to 20.75. Any issue on how to find the mean of a group data?
No issue, sir.
No, sir.
Let me make progress. Excuse me. Yeah. I'm
So,
with you. Ask your question.
for a group data, that's the formula for a group data.
Yes, sir.
Okay, sir. Thank you. What of the ungroup?
I hope for ungrouped, what you need to do, ungrouped, this is a group data. Ungrouped data may just have numbers like 3, 5, 7, 8, 9, 10. The data is not grouped. If you want to find the mean, all you need to do is to add the scores or the values or the set of distribution together and divide by the number. You divide by the number of the number in the distribution. For example, if 3, 5, 7, 4, 1 is before me to find the mean, all I need to do is to add 3 plus 5 plus 7 plus 4 plus 1, divide by 1, 2, 3, 4, 5. Because the data is not grouped. Once a set of distribution, a data is not grouped, all you need to do is to sum everything together and divide by the number in that distribution. But for group data, the scenario, the case is different. For group data, you will need to first find the midpoint. When you find the midpoint, you find f of x, f times x. When you find f times x, you'll be required to get the value of x squared. When you find the value of x squared, you will go ahead to find the value of f times x squared. So for the mean, it's just the summation of f of x all over some f, and which will give you this value. Oga Usiago, are you okay now?
Yes, sir.
So I'm making progress now to get the variance. With your permission, I want to make progress. With the permission of this class, I want to make huge progress now.
Permission granted,
Who
sir.
is chatting?
Go
That's
ahead,
fine.
sir.
That's okay. Who is chatting me up here? No issue. Okay, that's fine. Let's make progress. So for variance, the formula is sum fx squared all over sum. Let me draw it up. Okay, that's fine. The formula is sum fx squared all over sum f minus x bar squared. Sum fx squared all over sum f minus x bar squared. X bar means the mean square. Somebody was asking me last year, are you going to give us this formula in the exam? Nobody is giving you formula. I'm telling you now, nobody will give you formula. You have to know this thing upstairs. Somebody asked me last year whether I'm going to give them formula. I'm not giving anybody any formula. So you need to know it. That's why we're teaching you to know. You need to know it. Therefore, variance is equal to some fx squared all over some f minus x bar square, which is the mean square. And this is equal to this your sum fx squared. We'll sum it up from that column. We got 9205. And that's our 9205. Sum f is 20 minus the mean. The mean is 20.75. We said squared, so we have 20.75 squared. If you divide 9205 by 20, you will have 460.25. Excuse me. Hi. Now, 20.75 squared simply means 20.75 times 20.75 here, where you are seeing this cursor, and you have this. You subtract, when you do this small algebraic computation, you arrive at 29.6875. Any issue, ladies and gentlemen? Any issue? If there's no issue, I wish to make progress. Any issue?
Progress,
issue.
sir.
Progress, sir. It's okay.
Of course, you are aware of the fact that standard deviation is the square root of variance. Therefore, armed with this statement, arming you with this statement simply implies that I will take the square root of 29.6875 straight away. And if I do that, I will get approximately 5.45 as our standard deviation. Any issue? Distinguished ladies and gentlemen, any issue? Mr. Philip Keno, you have
Sir,
the
no
floor.
problem, sir. No problem, sir.
Sister Freda, any issue?
None, sir. Understood, sir.
Because I want people to ask your question. I'm in high spirit. When I'm playing around with figures, I didn't even we are meeting one-on-one. You should have been enjoying me because I love playing around with figures. Figures give me joy.
It's obvious.
Nice one.
It's obvious. You're enjoying yourself.
So,
I will
example
also
2.
enjoy it.
You have to enjoy. You have to make yourself happy. For me, playing around with figures give me joy. So you have to make yourself happy to be happy like me. For me, I'm very, very happy. Example 2, the cost of 30.
Even me here too, I'm so happy because as you are playing the figure, I'm just smiling, going through it.
Okay. Example 2.
That is interesting.
Discuss.
It's just that some of us were wondering. I hope this kind of questions will not come out too much in the exam.
Sister Patience. Sister Patience, go and read. Let me see who is chatting. Okay. Steven say we're all in high spirits. I hope so. Now, example 2, discuss of 30 students in a test we grouped as follows. This one we're going to be much more faster because we are already following. We've already followed what is. We're already following what I've explained earlier. In this scenario, discourse of 30 students in a test were grouped as follows. Why is this table so scattered like this? I'm already sharing my screen, so it won't work. Between 40 to 49, we have 2. The frequency is 2. That's the scores of 30 students in a test were grouped as follows. So those that scored between 40 and 49,
We are following it.
I just did something now. So that lets it look fine. Is it not finer now? I've aligned it.
Fine.
So the scores of 30 students in the test were grouped as follows. Between 40 to 49, we have 2 students. Between 50 to 59, we have 6. 60 to 69, we have 10. 70 to 79, we have 7. 80 to 89, we have 4. 90 to 99, we have 1. Therefore, you are required to find the mean, variance, and standard deviation of the score. You have to find the mean, variance, and standard deviation of the scores. Now, This course here is what I'm referring to as class. You know, I just choose to put class there. If not, you put score there. I just choose to put class there because I have between 40, those that score between 40 and 49, those that score between 50 and 59, 60 and 69, down to those that score between 90 and 91. You see that it's just one person. That means the person is exceptionally bright. I just hope that the whole of this class will fall between 90 and 99 in the exam. All these good people we have in this course score between 90 and 99. Therefore, we are moving ahead straight away to get our midpoint. And of course, finding our midpoint, the values here, all you need to do is to say 40 plus 49, 40 plus 49, divide by 2. That will give you 44.5. To get this other score here is 50 plus 59 divided by 2, you get 54.5. 60 plus 69 divided by 2, you have 64.5. And down to 90 plus 99 divided by 2, you have 94.5. As in example 1, 2 times 44.5, that's f times x, gives us this value, and 6 times this value gives us this. This times this value gives us that. 7 times this value gives us this value. 4 times this value gives us this value. 1 times 94.5 gives us this value. How do we get s squared? We can get the values under this column by squaring each of these values here. By squaring each of these values here. And quickly we have 44.5 times 44.5. That gives us this value. 54.5 times 54.5 gives us this value. And that is the approach we adopted. We get to 94.5 times 94.5, which will give us this value. How do we get fx squared? Fx squared, this is our f, all the values here are our f, and we have our x squared here. These are our values for x squared. So all we need to do is to say 2 times this value here gives us 3960.5, this value here, and get the next value here, 6 times this value, 2970.25, 6, this is your value for 6, times 2970.25, multiply these two together, 6 times this value gives us this value, and the procedure follows down to the last class. The last class here is 90 to 99. Of course, it's only one person that was brave enough to be in this category, and therefore, if you multiply 1 by this value here, you have this value. So quickly, without waste of time, ladies and gentlemen, sum f, that's I'm summing all these values here. If you sum all these values here, you will get 30. You get 30. And for some f of x, it's the whole of this value here. You get 2015. 2015. And if you sum the whole of this value here, we have some fx squared, which is equal to all that. Any issue?
No issue, we can proceed.
Okay, sir.
Sir, I want to ask. Sorry, sir.
Mhm.
Hello, sir.
I'm with you. You can ask a question.
This midpoint, is it compulsory I must use midpoint, or if I use X, is okay?
If you put X, I'm fine.
Okay,
Me, I
sir.
will understand you now. If it's in an exam scenario, you put it. Me,
Yes.
I will know now. It's
Okay,
just for
sir.
you to put the heading. Let me know that this is the heading.
Okay.
If you put X alone, me, I will know.
All
I
right,
will
sir.
not be bothered. Yes. Even
Thank
me,
you,
I
sir.
don't like. So if you don't like, don't put midpoint. Just put X. I know that it's midpoint.
Okay, sir. Thank you.
You're welcome. So straight away, without waste of time, we're moving ahead. Our main is as follows. Some f of x all over some f. When you put the 2015 over 30, you have that. And standard deviation follows, you have that. Any question? Any question?
I don't have questions, sir.
If you don't have question, with your permission, I wish to make progress.
Permission granted.
Progress, sir.
ANOVA, analysis of variance. ANOVA simply means analysis of variance. It's a statistical test used to check whether the mean, that's average, the mean values of 3 or more groups are significantly different from each other. ANOVA is a statistical test used to check whether the mean, that's average values of 3 or more groups, are significantly different from each other. Instead of comparing means directly, ANOVA compares variations. That's the differences. That's what ANOVA does. So variation between groups. Here, how far groups means from the overall means. Overall mean. Now, when ANOVA is used, when do you use ANOVA? You use ANOVA to compare 3 or more treatments, / methods, / products, / classes. The people in agriculture, they do a lot of, just a minute, somebody's knocking on my door.
This course is so long. Oh. I'm beginning to be afraid now.
So we'll see. Let's see on Monday. No. I'm just online. Sorry. So sorry. Some of my students that just came around. So I just told them we have a class. So let's make progress. So for ANOVA, when ANOVA is used, is to compare 3 or more treatments / methods. Just like I was saying before, these students knocked at my office door. The people in agriculture, if you go to my university, if you come to my university here, the agricultural people, especially crop production, the people in animal production, they use ANOVA a lot. They keep on looking for people that will help them solve their ANOVA problems. They will set up a table. They want to know whether there's a significant difference between the means. They want to know whether there's a significant difference between the weights of animals. They want to know whether there's a significant difference between the weight of the pigs, weight of the rabbits. ANOVA is used. So you will know this so that when they are looking for people that will do them analysis, you are handy. Now, ladies and gentlemen, example is comparing mean scores from 3 teaching methods, mean yields from 3 fertilizers, or mean recovery time for 3 drugs. Now, gentlemen and ladies, the key idea here is if the between group variation is much larger than the within group variation, ANOVA concludes that at least one group mean is different. If the between group variation is much larger than the within group, we have what we call between group variation and within group variation. Then you conclude that the ANOVA concludes that at least one group mean is different. So we have basically the types of ANOVA that we have one-way ANOVA, that's one factor, e.g. teaching method. Then we have two-way ANOVA, 2 factors, e.g. teaching methods and gender. But in this class today, since we don't have time, in fact, today is the last class. What do they call it now? Tuesday was completely off. That's really affected me psychologically. But then, no problem. At least we have tried our best. We'll do just one-way ANOVA. One-way ANOVA. Now, as an example, one-way ANOVA, a teacher wants to know if 3 teaching methods lead to different mean tests. A teacher wishes to know if 3 teaching methods lead to different mean test score. That is, I have my own teaching method. You have your own. The next person has his own teaching method as well. We want to know whether the mean average, when I take my own average, you take your own average, the next one takes his own average. We want to know whether there's a significant difference, and we're testing at 5% level of significance.
No audio.
Can you see my screen now?
We cannot hear you.
Yes, you can see your. Yes, can see your screen, sir.
And you can hear me now, isn't it?
Yes, it
Well,
is.
yes.
Okay, that's fine. A teacher wants to know if 3 teaching methods lead to different mean test scores. Now, method A has 8, 9, 6, and 7. Method B has 5, 6, 4, 5. Method C has 9, 8, 10, 9. So we are required to test at 0.05, that's 5% level of significance. Now, the very first thing you are going to do, you will state your hypothesis. There's what we have null hypothesis and alternative hypothesis. Null hypothesis, under null hypothesis, we say that there's no significant difference between the means. While in the alternative hypothesis, we say that there's a difference, at least one, in the means. So this is how we state the hypothesis before we start our computation. So here we are saying that there's no significant we are saying that all the means are equal. There's no significant difference between the means. This is the null hypothesis. We call it null hypothesis. N-U-L-L. N-U-L-L. Null hypothesis. This is the alternative hypothesis. The null hypothesis is represented by H0, while the alternative hypothesis is represented by H1. And in the alternative hypothesis, we state that at least one mean is different. At least one mean is different. Now that's step one. Step two, we compute the group means and the grand means. We're computing the group means and the grand means. So here we'll look at the group totals and the means, the group totals and the mean. And be very careful now. Be very, very careful now so that we move at the same pace. Under A, what we'll do here is we are summing all this sum. We are summing all this to have our 30. So when you take the mean now, the mean is you sum all this and divide by 4. First, under method A. I hope you are listening. You have to follow what I'm saying closely. Otherwise, once you lose track here, you have issue in the rest of the rest of the solution. So you see, this is method A. This sum here, that is 30. Under A method, I'm saying sum is 30. All you need to do is to say 8 plus 9 plus 6 plus 7. If you sum that, you get 30. Because 8 plus 9 gives us 17. 17 plus 6 gives us 23. 23 plus 7 gives us 30, isn't it?
Yes.
Isn't it?
Yes, yes, sir.
So that's how I said sum is equal to 30 here. Now, if you find the mean,
Honestly, I did not know.
you have to be attentive. You have to be attentive so that you follow what I'm doing. Francis, off your speaker, please. So to get the mean, now, for A, Olawuni, off your, because it's interfering with my audio here. Now, to get the mean, all you do is you sum 8 plus 9 plus 6 plus 7.
So your screen has gone off. Your screen has gone off.
That is showing. Gone up.
It's showing, sir. It's showing, sir. It's showing.
Okay, that's fine. Now, you will add 8 plus 9 plus 6 plus 7, divide by 1, 2, 3, 4, which is this. And if you add, that will give you 30, divided by 4, and that's 7.5. You will come to B. That's this B here. I said sum 20. The meaning is this. When you add 5 plus 6 that's 11. 11 plus 4, that's 15. 15 plus 5, that's 20. That's how we got this 20. And the mean in this case will be 5 plus 6 plus 4 plus 5 divided by 1, 2, 3, 4. And that's how we got 20 over 4, which is equal to 5. For C, I said sum is 36. And the reason is this: 9 plus 8 is 17. 17 plus this, that's 27. 27 plus this, that's 36. So that's how we got this 36 all over 4. And of course, obviously, it's 9. Now, the grand total. The grand total. The grand total now is your 30 here plus 20 plus 36 will give you 86. Will give you 86. Now, you want to get a grand mean now. You want to get a grand mean. You see this total here, 86 all over. How do we get 4 plus 4 plus 4? It's from here. You know, under method A, we have 1, 2, 3, 4. Our N1 is 4. Under method B, we have 1, 2, 3, 4. Our N2 is 4. Under method C, we have 1, 2, 3, 4. Our N3 is 4. Therefore, 86 all over 4 plus 4 plus 4 gives us 86 all over 12, which is equal to 7.1667. So far, so good. Can I make progress?
Yes, sir. You
Yes,
can
sir. Yes. Yes, sir. We are following.
Compute sum of squares between. Compute sum of squares between, and this is the formula. And the meaning of this formula here, this is your N1, this is your Ni here. I'll split this thing for you. You see this thing here, this is N1 into X bar 1 minus X bar square plus N2 into, although I've done it down here, each group has N equal 4, which I've explained earlier. Each group has N equal 4. Is this formula now I want to interpret for you, this formula here. For A, you know, accounted for up there, into, what is the mean for A? Let me show you. The mean for A is 7.5. This is the mean for B. This is the mean for C. So, the mean for A is 7.5 minus the grand mean. This is the grand mean here, squared, which is equal to 4. 7.5 minus this gives us that, and your square is there. What you do here is 0.3333 times 0.333, which will give you a value that you will use that value to multiply by 4, and you have this value. Any question there? Now for B.
No question.
For B, you have 4 into the mean up there is 5 minus the grand mean square, which minus the mean for BO. Now this is the for B. This is the grand mean. This is the grand mean. So we have this. The same process applies here. All you need to do, you say 2.1667. From here we got it squared. So it's 2.1667 times 2.1667 times 4. Get this. You have to do these computations all to confirm what is here. So for C, you have 4 into 9.0 minus 7.1667 squared is equal to 4. 9 minus 7.116. 9 minus 7.1667 is this squared. So all you need to do is to say 1.833 times 1.833. The value you get, you multiply it by 4, and you have this. Sum of squares between. Quickly is just to add these 3. Quickly to add these 3 values. And if you do that, if you dare do that, you have this value. Approximately, I just choose to truncate it at this point so that I will have 32.667. This sign is approximately, this sign is equality sign, equal to. Here is approximately. Any question here that if you ask, I answer you. If there are no questions, I make huge progress. Huge progress.
Progress. We understand.
When I give an assignment, I will know that you understand. This one, if you are saying, I want to give an assignment today. Now, you compute sum of squares within. Sum of squares within. So for group A, if you notice, the mean is 7.5. The mean is 7.5. So I'm going back to the table. Let me show you something. Each of those values in group A, I'm going to the table to show you something. For group A, I will say 8 minus 7.5. I will use 9. I will use 6. I will use 7. Group A. So I'm going, now that I've shown you what I want to do. So for group A is 8 minus 7.5 square plus 9 minus 7.5 square plus 6 minus 7.5 square plus 7 minus 7.5 square, which is equal to all that. Therefore, when you sum all these, this is the result. And I just hope you know how we got 0.25. We got 0.25 from here. 8 minus 7.5, the result you are going to get, you square it, you will have this. 9 minus 7.5, the result you get, you square it, you will have this. 6 minus 7.5, the result you get, you square it, you will have this. 7 minus 7.5, the result you are going to get, you square it, you will have this. Therefore, sum of squares within gives us 5. Any question?
No
Any
question. Let's proceed.
Any question, please?
Is under
Processor. Processor.
Can I make progress?
Yes, can make progress, sir.
Okay, fine. So, ladies and gentlemen,
We can make progress.
no, let me not say ladies and gentlemen, distinguished ladies and gentlemen, for group C, because you people are distinguished. And it's the same thing for C. I will go to the table, pick each of the values. Here, 9 minus the mean, 8 minus the mean square, 10 minus the mean square, 9 minus the mean square. And that's what I'm going to do downstairs. Ladies and gentlemen, for group C, we have 9 minus 9. The mean is 9. Square plus 8 minus 9. You do that and you have 2. So the sum of squares within is 5 plus 2 plus 2, which is 9. Now, if you watch closely, k is equal to 3. Why is k is equal to 3 is that we have method A, we have method B, we have method C. So that gives us k equal 3. N is equal to 12 observations. And I tell you, let's go back to the table and see how we actually got 12. You'll be counting like primary school children. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So N is equal to 12. Is there anybody contesting why N is equal to 12? Any contestant?
No,
sir.
Let's make. So, once again, distinguished ladies and gentlemen, the degree of freedom between is k minus 1. That is the formula for degree of freedom between is k minus 1. And in our instance, k is 3. So 3 minus 1 gives us 2. The degree of freedom within is capital N minus k. Ladies and gentlemen, we just established the fact that N is equal to 12 and k is equal to 3. 12 minus 3 gives us 9. Gentlemen and ladies, degree of freedom total is capital N minus 1, which gives us 11. Anybody contesting this arithmetic computation?
no,
I'm making progress, please. Step 6 is mean square. The mean square between is the mean square between all over the degree of freedom. And the SSB, I hope you know where SSB is. Let me show you SSB. This is our SSB, 32.667. 32.667. Of course, just a while ago, I intimated you of the fact that degree of freedom between is 2. So, this all over 2 is 16.3333. Now, the mean square within, this is the formula SSW. Of course, you know your SSW. Let's go there. Let me show you SSW. Sum of square within, your sum of square within SSW, your sum of square within is the addition of A, sum of square within of group A, group B, group C, and when you add everything up, you have 9. And I quickly insert this there, insert it here, and I have 9 over 9, which is equal to 1.0000. Yes, since here is 4 figure, I have to make this equally 4 figure. Now, for your F statistics is MSB. This is your MSB all over MSW. That's mean square between and mean square within. This all over that, which is equal to 16.333 all over 1.000, which gives us 16.333. Now, critical decision. Ladies and gentlemen, at 5% level of significance, the degree of freedom for 1 is 2 and that of 2 is 9. I show you. The degree of freedom between is 2. The degree of freedom within is 9. 2 and 9. 2 and 9. So that's what I'm calling 1 and 2. The degree of freedom for 1 is 2. For the second one is 9. Now, when you go to your F statistics, at 0.05 level of significance. I'm going to give you, I will send you the degree of freedom. What do they call it now? The F statistics statistical table. The degree of freedom,
Okay.
you will see degree of freedom this way, and you will see the level of significance this way. That's why on the table you see slash. So you will check where you have the degree of freedom 1 and 2. You will check where you have 2, 9, and you will straight away, you will check where you have 2. At 5% level of significance is the intercept. Where it intersects, you will observe that it's here. I'm going to send that table. I'll send that table today. And I will, when I print it, I will actually show you on the table how this value is gotten. 4.26. So since the value, this is the conclusion. This is the conclusion. Since the statistical value is less than the calculated value, since the tabulated value is less than the calculated value, we conclude that there is no significant difference in the means of the teaching method. Had it been this value, the tabulated value is greater than the calculated value, we will reject the null hypothesis and accept the alternative hypothesis, stressing that there's a significant difference between the means of the teaching methods. But since this tabulated value, the one we got from the statistical table, is less than the calculated value, the F value, we conclude that we are going to accept the null hypothesis and stress the fact that there's no significant difference between the means of the teaching methods. Gentlemen and ladies, distinguished ladies and gentlemen, I wish to say that I rest my case at this point to pave way for good questions, reasonable questions coming from your ends so that I can attack immediately. You have the floor, ladies and gentlemen.
Excuse me, sir.
Mr. Francis Woodley.
Okay, sir. In terms of setting up the hypothesis, what if you decide to set up the null hypothesis? And from what we've gotten now, what if we just say we refuse to reject the null hypothesis?
Why will you say you refuse to reject the null hypothesis? The rule is that the tabulated value, the value from the statistical table, if it is less than the calculated value, you accept the null hypothesis and reject the alternative hypothesis. However, if the tabulated value is greater than the calculated value, you reject the null hypothesis and accept the alternative hypothesis.
Okay. But I think if you listen to the grammar, you refuse to reject the null hypothesis.
Where did I say refuse to reject? Did I write it anywhere?
No, I'm just asking, what if you write that way?
I'm teaching you a statistical way of answering this question. You will say, since the tabulated value is less than the calculated value, you accept the null hypothesis and reject the alternative hypothesis that there's no significant difference between the means. If the tabulated value is greater than the calculated value, you reject the null hypothesis and accept the alternative hypothesis that there's a significant difference between the means of the three teaching methods. Remind me, I'll write the conclusion here for you. Just remind me on the WhatsApp page. As I'll put finishing touches to this, I'll put the conclusion here. Then I'm gonna, the other ones too, I will work on them and still put it on the platform. Any question, any further question? So if there are no further, okay, Simeon.
Yes, sir. Okay, thank you so much, sir. So, sir, my question is, assuming this kind of question is given, are you going to provide the F tabulated for us so that when we calculate, we now compare it?
Yes, if in the exam, the F table will, yes, if will be given to you. In fact, I will make photocopy. I will print maybe one or two. Anybody that needs, I will just give the person to check.
Okay, so I was thinking you just place the value in the question so that we only calculate and compare directly.
I think you can go online and still get it now. You can get F table online.
Yes. You can get your F table online, sir. I think if there are no further questions, all the concerns, I'm going to put them on the platform. Then we'll arrange on how to do our revision before the exam, isn't it? At least during the exam.
Yes, sir.
Yes, sir.
That's very important. Very important. Revision. Very important.
So
areas of concern.
Very much,
Hello, Doc. Hello.
O'clock.
We are quite a few village now. I was shooting over.
Moga aka macam Benjamin Benjamin John. Qual a fraction so?
We should keep going.
Saya nama material so. Nama material.
This is two monthly more.
Sir, I forgot to give out assignment.
Go practice. Go practice now. Go practice on your own. I'll not be a while like that.
You have plenty of assignments yesterday. Have you finished them?
I wonder. Go and practice on your own now.
They give you work, you are still demanding for more work.
I wonder. If I say no get another work to do.
Leave her now.
Nah, he never marry you. Nah, young man.
This 707, how many assignments has he given? No, it's one, but
It's only one, but he said we should do the exercise in this thing. Oh,
No.
he
Class
not
over.
giving exercise now.
huh?
Which exercise again?
No, all those me mode and media, something like that. Those exercises that are there. He said we should practice them.
That
Yes,
means expecting
we are
something.
not going to commit. Apart from that other one, I think there's no any other assignment.
Okay.
Did he give any deadline for the submission of the assignment?
He told us yesterday that it's today now.
He said that we should commit it today. Today is the last day. You can submit
Questions,
through
I
his
think
email.
Professor, I didn't follow up.
You are good in mathematics, I know.
I'm not good like that, though. How far now? We'll chat inbox a bit.
Network.